Morning, everybody. What are we doing today? We're doing some symmetry, okay? What do you remember about this? I'd say two things. What do you remember when we talked about it last week? You divide a shape evenly. So you could have two parts, right? After you divide it, it's congruent on both sides. And you can divide it horizontally, vertically, diagonally. There's a lot of different ways to do it sometimes. And you have to be able to fold it evenly. Because sometimes you can actually divide a shape so it's congruent on both sides, but it doesn't fold. Maybe we'll find some of those, all right? So let's look at some symmetry today. You guys might be doing yours digitally. If you don't print it out, that's fine. If you're doing it on paper, just see if you can grab a ruler or something straight, okay? All right, this says, draw all lines of symmetry. If an object is not symmetrical, place an X over it. So I know you checked it, okay? All right, let's start with this guy. Looks like we've got a trapezoid. Looks like it's on its side here. Well, if I draw this line down the middle, is that going to be even on both sides? No, I don't think so. So it's not symmetrical vertically. Maybe I could try it horizontally. Oh, that looks pretty good to me. So let's draw this line. And the line of symmetry is usually perpendicular to a side. So that's a little right angle there, isn't it? It's a right angle there on that side, okay? So these are even, and if I fold this one onto this one, it's going to match up, okay? All right, cool. How about this guy? I got a triangle. Look, two sides are the same. It's isosceles. Let's try my vertical again. Definitely not. How about horizontal? Yep, looks good to me. Let's see if I can make it from the corner to the side. So check out these two. This one went from a side to a side. This one went from a side to a corner. And it's definitely foldable. It's congruent on both sides. All right, I got a parallelogram up here. This one looks pretty interesting. Well, not horizontal, not vertical, right? Even though they would be congruent, they're not going to fold, are they? What about if I went corner to corner? Are they congruent? Yeah, it's kind of like a puzzle piece. Like I could kind of turn this around, it would might match over here, right? But if I folded this top one down over here, I don't think it's going to match up, right? So it's not symmetrical because you couldn't fold it, okay? All right, so that was a parallelogram. How about this rhombus over here? Well, could I go this way? I don't think it's going to fold. They'd be congruent, but I don't think it's going to fold. And it probably means that way is not going to work either, right? How about top to bottom? How about vertical? Yeah, that's going to work. So let me go corner to corner. That looks pretty good. Is there another line of symmetry? I bet I could go horizontally, right? Yeah, that looks pretty good. All right, corner to corner. Straight across. Here's another little tip I like to do. I'm going to put a little 1 here. That's one line of symmetry. There's a 2. That's 2. That's number 3, right? Should I put a 3 there? If I put a 3 there, aren't I just counting the same one twice? So you got to be careful. Make sure you only count them one time. So this says 2 lines of symmetry, vertical and horizontal. Okay, how about up here? This is kind of funny. Probably not that way. Not quite. I don't think this one has any symmetry, guys. I got an arrow down here. What would you call this? Let's count the sides. 1, 2, 3, 4, 5, 6, 7. 7-sided polygon. I think that's a septagon. Which way? Yeah, I don't think so. I don't think so. How about, yeah? So let's go from corner to side. If I have a ruler, I can probably get it pretty neat. So look, this side's going to be perpendicular here. It should go right to my corner. Cool. Even on both sides, I can fold it across. One line of symmetry, okay? Okay, I've got a hexagon. It's an irregular hexagon. Let's bring it into focus here. Now, I can definitely go across. I can definitely go corner to corner. And I think I can go top to bottom. Let me see if I can find the middle. What about this side to this side? I think it would be congruent, but I think because it's an irregular hexagon, it's a little bit too long. It's not going to fold properly, okay? So here's the secret. I used an irregular hexagon, but if it was a regular, if it was a little bit shorter, you would be able to go from corner to corner and even side to side. But this one's just a little bit too irregular, okay? But a regular hexagon, a regular pentagon, those have a lot of lines of symmetry, okay? All right, last one here, the old square. I bet you know this one. Definitely horizontal. About a vertical too. And that's it, right? No, this one's got some more. I think I can go corner to corner. If I can go that way, I can probably go this way. How many? 1, 2, 3, 4, 5, 6, 7, 8. Right, guys? No, don't fall for that. 1, 2, 3, 4 right there. That's the last one because this is number 1 again, isn't it? Okay, because it goes the whole way through. If it's a rectangle, then it would just have 2. No diagonals on a rectangle, okay? All right, we checked them out. Let's check this thing out. This is what I want you guys to do. If you're doing it digitally, that's fine. Draw the lines in, send it back in, okay? I got 1, 2, 3, 4, 5, 6, 7, 8 shapes, I think. Just keep in mind, this is a regular pentagon, and this is an equilateral triangle, okay? Looks like we've got an isosceles, a right, rectangle, pentagon, irregular, pentagon, a couple other things for you, okay? All right, draw the lines of symmetry. If it's not symmetrical, just put an X like we did, okay? All right, give it a try. I'll take a look and get back to you, and have a good one.